Hello friends, welcome to the next class of computational physics. In this class, we will learn few examples of algorithm. Now, while writing any algorithm, we know what to do and what to not do. We have some specific step-by-step instructions to develop an algorithm. Now, let us follow all these instructions of previous class and build some simple algorithms. Now, before writing any algorithm, there is one important note. That is, while assigning any value to the variable or in an expression, we will use either arrow or equal to sign. What it means? So x equal to 2 means the 2 value is assigned to x. Similarly, if you want to go from one step to another step in an algorithm, then we will use go to. So go to means it will help you to jump from the within steps of algorithm. Such, for example, go to x, that simply means transfer the control to step x. Now let us see a very simple algorithm for addition of two numbers. So this is an algorithm which will help you to understand how to get addition of two numbers. So first step is start. While writing any algorithm, the first step is always start and the last step is always end or stop. Now second step is read any two numbers, let's say a and b. Now step number 3 is do addition of both the numbers. So c equal to a plus b. C equal to a plus b. What it means? It means add the value of b and a together and assign that value to c. Then print the value or display the output, that is value of c. And step number 5 is end or stop. So this is a simple algorithm for addition of two numbers. Similarly, see another example, that is algorithm to check whether given number is positive or negative. So first step is start, second step is read any number, let's say p. Then step number 3 is check whether the number is greater than or equal to 0. If number is greater than or equal to 0, so if yes, go to certain step, that is 4, else go to step number 5. So logically, if you look towards the condition, that is p greater than or equal to 0, yes means p is positive. So step number 4 will be print or display the output as given number is positive and then go to step number 6. If the condition fails, then go to step number 5. So step number 5 is given number is negative and step number 6 is end or stop. Now after step number 5, it will logically or directly go to step number 6. So here you can see, if condition is true, so this will transfer control to step number 4, and after step number 4 it will transfer control to step number 6. And if the condition fails or if it is not true, then it will go to step number 5 while skipping the step number 4, and after that, after execution of step number 5, it will transfer control to step number 6. Okay, so this is second algorithm. Now see third, that is addition of n integers. So let's see, step number 1 is start, step number 2 assign sum equal to 0, step number 3 read value of n, so assign x equal to 1. Now while x is less than or equal to n, what is n? N means addition of n integers, how many integers you want to add, that you have to provide as an input. While x is less than or equal to n, do sum equal to sum plus x and x is equal to x plus 1. Means add value of x to sum and give that value to sum again, and after that add one value to x. So do increment in x by 1 and assign that new value to x. Then print value of sum, end or stop. So once the condition fails, it will print the value of sum. Till the condition is true, it will do these two processes, that is sum equal to sum plus x and x equal to x plus 1. Again it will check whether x is less than or equal to n and so on. Once it become greater than n, then it will print the value of sum and the algorithm will stop. So this is the algorithm for addition of n integers. Now this is very important algorithm to study the Fibonacci series. Now what is Fibonacci series? Fibonacci series means it will allow you to generate a series of different numbers. So first step is 0, second step is 1. So accordingly, the next step will be 0 plus 1, that is equal to 1. So what it mean? It means the Fibonacci series generates the successive number by adding two previous steps. So third step is addition of first two steps, fourth step is addition of second and third step, fifth step is addition of third and fourth step, and so on. So for that, let us generate the algorithm. So first step is start, second step is assign first term, f1 is equal to 0 and f2 is equal to 1. Now here you have two terms, hence count is equal to 2. Then read the number of terms which you want to generate for this Fibonacci series, that is equal to n. So n means number of terms in a series. Then print first two terms, that is f1 and f2, so it will print 0 and 1. Now calculates third term from the values of f1 and f2, so f3 equal to f1 plus f2, then print f3. Now here you have increment in count, so count become equal to count plus 1, so it will be 2 plus 1 equal to 3. Now here you can see 1, 2 and 3 values. Now if count is greater than n, go to step number 10, else alter the values. Now this is very important step. Once count become greater than n, you have to stop. If it is not greater than n, that means you have to continue the process. But while continuing the process, now assign the value of f2 to f1, assign the value of f3 to f2, and now you are ready to generate new f3. Go to step number 5. So it will again calculate f3, print f3, increase count by 1. If count is greater than n, stop. If it is no, then again give value of f2 to f1, f3 to f2, and so on. So this will continue until your count become greater than n, and once it become greater than n, the process will stop. Now let us see how this algorithm will execute. So start, assign first term, f1 is equal to 0, f2 equal to 1, count equal to 2. Now read any number, read the number of terms in a Fibonacci series, that is n, let's say 10. Now print first two terms, f1 and f2, calculate f3, this is print f3. Then count equal to count plus 1, and if count is greater than or equal to n, go to step number 10, else alter the values, go to step number 5. Now see here, for count 1 you have f1 is equal to 0, for count 2 you have f2 is equal to 1, for count 3 you have 0 plus 1 equal to 1. Now similarly, so here you have first iteration 0 1 1, for second iteration you have 1 1 2, so count become equal to 4. Then for third iteration 1 2 3, then for fifth iteration 4th, 5th, and so on. So here you can see the series 0 1 1 2 3 5 8 10 21 and 34. So your count become equal to 10, so the process will stop. So this is the execution of algorithm of Fibonacci series. Similarly, consider an algorithm for swapping of the value of two variables. So start, read any number of values, let's say m and n. I want to swap the values of m and n. What it mean? It means assign the value of m to n and n to m. But the variable can take at one value at a time. So you need another variable, let's say L. So L equal to M. What it mean? Give the value of M to L. Then give the value of N to M, and after that give the value of L to N, and then calculate, this is not the step, the print the value of M and N, and then stop. Now here you can see you have M and N, you have given value of M to L, then you have given N value to M, and whatever value of M, previous value of M that is stored in L, that value is assigned to N, and then you have printed value of M and N. Let's say M equal to 2 and N equal to 3. So L equal to M, that simply means L equal to 2, then M equal to N, that simply means your M become equal to 3, N equal to L, so that means your N become equal to 2. So if you print it, here you can see your M become equal to 3 and N become equal to 2. So in this way you can alter or swap the values of variable. Next, let's see the algorithm for ideal gas equation. Ideal gas equation is PV is equal to RT. So I want to calculate the value of pressure at different volumes. So that means I require initial volume, final volume, then increment in volume, R and T. So let's see. V equals equal to VI. Calculate P is equal to RT divided by V. Now V equal to V plus dV means increase the volume by dV. Then print value of V and P. Check whether V approaches to final volume, that is V is less than or equal to Vf. If it is so, then go to step number 4. If it is less than or equal to, then calculate the pressure again, and once it become greater, then stop. So in this way you can generate the values of pressure for different volumes. So this is all about the algorithm and its examples. In next lecture we will see the flow chart and its examples. Thank you.